All right, hey everyone, Spectre, you must be aimbotting. I've been keeping track, but that has to be the fastest first that I've seen. But yeah, I hope you guys are doing good. And Jed, hi. We got some DMs. Let's see what's up. Or not. Come on. Shoot. One second. There's just a thing in. I just got a Discord notification. It's not even important, but I can't deal with a notification like being there, and so I just have to like quickly skim it. Okay. Now let's look at my DMs. Wasn't even available. Wow. How much of a god you are. Okay. Okay, this person. It was just a little like a proof thing. They had to show that for a polynomial of degree n, it has n-1 many critical points, and I posted something about using when you derive a polynomial, the degree becomes n-1, and then from the fundamental theorem of algebra, you can basically get to this exact equation. And I guess the thing that I linked is probably a little bit too much, or like more than this person needs. So this person does make a good point that I could have gotten a better link. Wait. Really? You factor out an x squared, you get x plus 1. Wait. I need to look up what this actually... I thought it was true. That person was saying... Is that an inflection point? I guess it would be. But no, but they're not asking about inflection points. Oh. It is an inflection point, but not, I guess, not by this person's definition, which is a little weird. Check the image. Yeah. Okay, these are the normal definitions for minimum maximum for A and B. For C, wait, the first derivative has to be 0 for an inflection point. That can't be right. Hey Prev, you can type them out there in Twitch chat, or if it's easier, you can put them in my Discord. I have a math questions channel there. I'm best with things that are like calculus and below, so I'm not sure what type of question you have, but it's kind of my general like skill level. I never heard of the third derivative being important for this. Huh. Yeah, I forgot that the inflection points can mess this up and make it not true. I think with that person's definition that they posted, it's still true. Hey, Jura. But when I typed out my initial response, this should have raised a bigger question mark with me. because I think the other person does raise a valid point that the points of inflection messes up my argument with the way that points of inflection is usually defined. What's that? Oh, let's see, Prav posted. Oh gosh. Let's look at what Prav posted. I don't have any competition experience, no, and I'm not particularly at competition problems, and this kind of looks like one, so I don't know if I'll be able to do this. I'm not doing that, Truha. Actually, I'm gonna type it in off stream, so I want to know what you typed. Okay, just polynomial. Jura, I'm not going to do that. You've got me that exact way before. I'm not doing it again. I never heard of undulation point. So, would we just look at the factors of 2005? Well, and see which one gives a perfect square? And then we have to engineer x, y's, and z's that give us that number? It's stationary? I never heard of a point of inflection not being stationary. Oh wait, but none of these are perfect squares. So is the answer nothing? Oh wait, unless we can have... Okay, okay, it is. Yeah. I was trying to think that there's something weird with like decimals. Oh, that's cool, Prav. Inflection? Huh. It's a cool way to spell it. Point of undulation. Its second derivative vanishes, but does not change its sign. Is it? Oh, I think that's just a special kind of inflection point, I guess. Which, do they give an example of that? I guess not. You'll be redeemed if you just have a good streak of not being a jerk, basically. That's all you have to do, really. No. An inflection point is... I know I'm asking a lot from you there, Truha. An inflection point, the way that I was taught is when the second derivative equals 0. It is possible for them to be the same, I think. But you usually run into them with like, basically the example that the other commenter posted, where this is the minima and the maxima are not inflection points because the second derivative is always negative all the way up until this like halfway point. Dan, I know, because that's what we're debating right now, because the person who posted the original Reddit thread had a different... Yeah, so you can also figure out using the first derivative and making like a sign chart. The way that I was taught originally is to just use the second derivative and find the zeros of that, but they're equivalent methods. This person learned some other weird third thing involving the third derivative though, which I've never seen before. Okay. Like, this definition seems really restrictive for an inflection point. Because if this first derivative has to be 0, that means it also has to be a minima or a maxima. And it's possible to have them both be 0, but it's just not very common in the problems that I encountered. But I guess, that's where the third derivative part comes in. So weird. So I already posted once in this thread, and I overlooked that important point about the inflection points. But I think I kind of got saved by chance with this person's class having a weird definition for inflection point. Yeah. So let me I'm gonna reply to this person saying, because this person pointed out a good like criticism of what I said, which I linked a way too complicated page in the fundamental theorem of algebra, and it's actually not as complicated as I was making it. To be for the sake of this problem. Other commenters made a good point about the points of inflection, but I think my logic still works with the definition point of inflection OP was given in their class. I think it's all like, I don't want to delve too much more into it than this, I think, because if this person is saying that for the sake of their class, that's not considered an inflection point, then I'm not really going to question it, because that's just the way the professor chooses to teach it, or lecture, I guess. And the problem just doesn't make sense if we don't use that classification thing. So yeah, I'm just gonna post this and call it good. This person just said thanks, but what was the problem? Oh yeah, they had to get a quadratic in this form, but they were only taught vertex form, which looks slightly different, and they're getting confused on like, you know, why does this look slightly different from normal vertex form? Thank you, Dan. Makes me feel better about what I said. And I just explained that it really is vertex form, it just looks slightly different. And I don't know why they need it exactly like that. But I don't think there's anything further to add. Let's see what the other person said here. Combinatorics? I'm horrible with combinatorics, Prav. If you only can post it and someone might be able to help, but I'm not good with combinatorics. This person asked a very open-ended question, which is they just have a lot of dirt and they want to get a convenient way to weigh it. And I said, figure out a shape that kind of approximates what the dirt is, measure the dimensions of it, and I found like a fudge, or you know, it's kind of like an average-ish value of the density of dirt that they can multiply by. This person raises a good point with when I say the difference between loosely packed dirt and tightly packed dirt. But I think that's kind of overkill for this person's purposes. But I'll also reply. You're right. How the dirt is packed will make. Actually, let's see what other people posted before I actually hit post on this. Yeah, Jen. I mean, you could make the argument though that you want to know if they're cheating you or not, I guess. Oh, this person, it's a pretty good technique too. With, instead of just using a number that I got off Google, actually measure the density of their dirt. Get a really big scale. I do like that person's idea of, just get like, you know, a cup full of dirt and measure how much it weighs and use that as your density. Weigh it? Someone's on your same wavelength, Dan. Make a big difference. Of how exact OP needs to be with their calculation. What I posted above is just a nice, quick way to get a number, even if it's a bit off. Okay. I think Prab posted their question. Okay. You find every function that satisfies the following. Is this the combinatorics one? Doesn't look like combinatorics. Unless maybe it involves it in the calculations. Oh, maybe this other one is? So for this first one, find every function that satisfies the following. I feel like I have half of a quarter of an idea of how to do this problem, but I don't really know. I don't really know what that means. I mean, I guess if you, so it looks almost like you could factor the x out from the inside and just look for functions that are unchanged if you multiply them by x, which I'm not sure what kind of function that would be. And I also noticed that this part on the inside on the left, if you added y squared, you'd be able to factor it as x squared plus y squared. I don't know if that's helpful though. Yeah, I'm not sure how you do this problem. Let's quickly look at the other one. The numbers 1, 2, 3, n are written in order on the blackboard. The following moves are possible. Whose sum is a multiple of 3. Oh. Yeah, I definitely don't know how to do this one either. Oh, I misinterpreted the little like multiplying by x thing. I'm gonna show Prav's solution to the first problem that I showed. The second one I have no clue. But if you don't want to see the solution that Prav posted to this one, then look away for a minute. Okay, so this is what I was trying to figure out in my head, but I thought the function would have to be unchanged if you multiply by x, but it's not that. It's just if f of x squared equals x f of x, and I guess that means it's odd. It's just any linear equation with y-intercepts of 0. Wow. I don't get this second part, but then I'm really not good at these questions, so I guess I wouldn't expect myself to. All right, let's look for homework questions. Let's see if they have an answer. Wait, they're microbiology and they have to do abstract algebra? Why? By the way, this isn't a real, I can't really answer a question like this, but I do feel bad for them. I just don't have, I'd rather just do math though. It's ridiculous that, I don't know why microbiologists would need abstract algebra though. Let's go to homework help. Really, Lily? I mean, maybe. I haven't heard of that, though. That seems weird. Like, I majored in math, and I was able to avoid abstract algebra. Let's see if I can remember this. Transform. Rotate. 270 degrees. Okay, there we go. I do remember it. God, we got Dutch. Oh, you don't know? Okay. So they're asking how they go from the integral, or I guess the integral here maybe, to the thing with ln. They call it the primitive, but I guess that just means non-involving integral. See if I can make it a bit bigger. Oh, that's not bigger. This is a very odd setup for a problem. So it seems like they start with this. Simplify it to 4 pi plus pi integral 3 to 2. They multiply out this squared. I don't know if this is like the student's work or if it's like actually given to them, but this multiplication looks correct. And so they go from this down to this, and they scramble around the terms. They actually reverse the order, just maybe where this person is getting confused. So we can definitely explain this one. They get the ln, but not the other. Okay, so they understand 16 over x minus 1 integrates to 16 ln x minus 1, but I assume they don't get the 16 over x minus 1 squared. Okay. 4x, or, since you say you already understand where the ln comes, oops. I assume you're more asking about the minus 16 x to the minus 1 term. That comes from integrating 16 over x minus 1 squared. So I'm going to explain this, I guess, the long way, using a u-sub. Sub with u equals x minus 1. Du equals dx to get 16 over u squared. We can bring the u, let me make this a new sentence. U up to the numerator if we make the exponent negative. So we can also say it's 16u minus 2. Then we integrate using the power rule. So we add 1 and divide by the new exponent. We integrate, we get 16u minus 1. Prav, I'm currently unemployed unless you want to count this. Basically, at my last job, I saved up a lot of money, and I figured I could take some time off work and try this out, see if it goes anywhere, because I think it'd be a cool job. I've been a tutor before, but it wasn't my last job. 16u to the minus 1. Now unsubbing, we get 16x minus 1. This one. Or we could also write 16 over x minus 1. Okay, so I hope this makes sense to them. I assume this is all they were wondering about. Because I hope they know how to integrate 4 into 4x if they understand the 16 over x minus 1 into 16 ln x. Oh shoot, did I dropped the negative sign. Oh, also I didn't say we get. Divided by -1.
You are technically correct. The best kind of correct.
Equals -16. You. I don't know. There we go. I dropped that minus sign, that was bad. Okay. Hopefully that helps. Let's look at this one. X equals 2, x equals 5. Oh, okay. What did they write? Why does this involve e's? Oh, that's how they draw x's. Whoa, I've never seen an x drawn like that. That doesn't even seem like it saves time. Because you still have to do 1 slash, and then you do the weird curly 8 thing for the other slash. I want to see them actually draw the x. But the answer to this is no, because you can take this x minus 2, x minus 5 thing and stick any constant you want in front of it. So there's infinitely many answers to this problem. But their particular answer is correct and completely valid. Let's look at the second one. A turning point, I guess it's just a vertex if we're talking about quadratics. Oh, we need to use vertex form. They also want a unique answer. This one will be unique. Ooh, will it? I think it has to be unique if you're determining the vertex and a point. Let's actually go through and solve this one. Just kind of interested to see what it looks like. Okay. Let's try black. So let's use vertex form for this question. Y equals a x minus h squared plus k. Coming down here, they gave us the equation for the vertex, or the point of the vertex, which they call a turning point, but I don't see what else that could possibly be besides the vertex. The x-coordinate is 3, so we do x minus 3, because there's a minus sign in the formula, squared. And the y-coordinate is -2, so I shouldn't have written the plus so hastily. And now we're given one other point. Oh, we almost have everything we need, but we need to get a. And we do that using the other piece of information that we're given, which is it passes through point 5, 18. So let's plug that in for x and y and solve for a. So the y-coordinate is 18, so 18 equals a 5 minus 3 squared minus 2. Add 2 to each side to get 20 equals 5 minus 3 is 2, 2 squared is 4, times a is 4a. So now we divide each side by 4, we get a equals 5. So the final answer is y equals 5 x minus 3 squared minus 2. Okay? And that one is unique. There's no other parabola that has those exact same two qualities. without being the same parabola, I guess. Okay. This submitted 2 days ago and no one answered it? Wow. There's a different but equally valid answer, equally valid answer you could have given. For the first one, y equals x minus 2 times x minus 5 fits the criteria, but so does y equals 2x minus 2 times x minus 5, or any constant you wish to put in front. For the second one, I'm interpreting turning point as the vertex of the parabola. We need to plug this information into the vertex form of a parabola. Y equals a x minus h squared plus k, where h comma k is the vertex. So let's plug in, what was it? Wait, I did an extra space. Oh no, I didn't. For h comma k to get. Yeah, I'm not sure how much of a hint I want to give the person for the second one, because I mean, they did kind of post their work for the first one, so I might give away the entire answer. I haven't, I guess, gotten to that part yet, for how much I'm going to give them for the second problem. X minus 3 squared minus 2. We only need to find what a is now. So plug in the point we're given, 5, 18, for x and y, to solve for a. We want to know uniqueness. Oh, I see what you're saying, Brian. Sorry, I misinterpreted that. Yeah, you're right. An answer. Okay, that's a good point. Thank you for that. An answer is unique if there's a different but equally valid answer you could have given instead. To address. Oh, thank you. No, please. That would have been a horrible mistake to make. That, you know, that's actually a save right there. Oh my god. Okay, so yeah, an answer is unique if Should I say not unique or should I say if it is unique? There's only one possible answer you could give for the question. And it's not unique if multiple solutions would work. Okay. Thank you for fixing my phrasing there. Unique, the answer is implied by the work we've done, but you could also plot the points plot 3, -2 as the vertex in the point 518 and try to draw multiple parabolas through those points. If you can draw multiple parabolas, then it's not unique. Okay. You're a middle, you might be a middle management warrior. There you go. I don't know. Let's see what Sakami has to ask. Ooh. Let me make this bigger. Is someone else already typing though? No, it's still just the original person. You bounce a ball to your friend from a height of 1 meter. You catch it at a height of 1 meter. The ball follows the path of the curve. R of t equals ti plus 2/3 t squared j plus t squared k for a is less than t is less than b or equal to. For all distances measured in meters, determine a and b and find how far the ball travels. So this is determine A and B. Ooh. Three A B series. It's the off-brand version. So to do this, I think, so if you, the 2/3 t squared, I think my theory is that you would figure out A and B based off the y coordinate, or maybe it'd be z. Z makes much more sense. It depends on how you define, is height y or z? That seems pretty important and ambiguous here. I assume it's z, because it doesn't make sense to use y. But you basically figure out where the parabola t squared starts at +1 for when you throw the ball from a height of 1 meter, and then where you see his height or right. Because you can't do the same logic with the cubic, so. But with a parabola, it's nice because it'll start at 1 and then it'll end at 1. Yeah, that's a little bit weird of a trajectory. It doesn't really make any sense, but it makes the question easier. So a should be -1 because -1 squared is +1. And then b should be +1 because 1 squared is 1. And now that you know a and b, you use the formula for arc length. Okay, so I think I know the process now. The thing is, it already has someone who's responding to it, so I don't know if I want to like jump in here. I guess this person asked this was a specific question. This person answered yes, so maybe I shouldn't type here again unless they ask another question. Well, let's see. K is the only one that bounces. That's a good point. Yeah, it has to be that. Otherwise, it'd be a really weird ball. I throw it at the ground and it just like keeps going down, or like somehow just starts going up. I don't want to jack this person's thing while they're already helping. So I'm gonna give it like a minute or two, and if that first person doesn't respond back, I'll jump in. It bounces negatively. Tooth? So we can find the equation of a tangent plane for this function, I guess. Why is this incorrect? That feels like my recollection of how you do this. I guess let's work through this for ourselves and see if we get the same answer. How long's it been? Okay. I'll leave that one for another minute. Come on, Opera. You can do it. There we go. That's a little bit too big, isn't it? That's what she said. It's probably not going to be too readable, but I'm just going to I'm just going to leave it like that. Actually, it's not even, it's zoomed in too. It's going to make it even worse, but the problem was cut off otherwise. Oh shoot, and that messed up. Ugh. Actually, it didn't mess it up that badly. Okay, that's probably not readable, but let's just deal with it. I'll rewrite the original function and the all that. F of x comma y is equal to 0.2x to the fourth plus 0.8 y to the 6, was it? 6 minus xy at 1 comma 0.8. So first let's find our f sub x. So doing the partial of that in terms of x, we bring the 4 down, we get 0.8x cubed. That derives to 0, that derives to minus y. F sub x of our point, 1 comma 0.8, is equal to 0.8 minus 0.8? Okay. Just roll with it. Let's find our f sub y of the original. That goes to 0, that becomes 4.8. y to the fifth minus x. Then our f sub y of that point. Okay, I just need to make sure I'm not getting cut off by the problem. 4.8 minus 0.8 is 4? I did this backwards. No? Yeah, I did this backwards. 0.8 to the fifth? Who knows that? Wait, so I got 0 for my f sub x. This person got 0.8, which is interesting. Which is cut off a bit. Okay, let me expand this back out. Hey, no pro. If you want to go ahead and post it, feel free. I do have some more questions that I'm doing right now, which I tend to prioritize, but if there's some, after I get through these two, I can take a look at you, at yours. So 4.8 times 0.8 to the fifth minus 1. Hey, Central. How was your run? .57. Oh, God. Oh, why would they give them such a weird number? Are they supposed to round? Lots of fighting? Ooh, nice. 2 decimals. Okay. Deaths and kills? Sounds like a good day. Okay, so I'm going to call that .57. So I get 2 different values for f sub x and f sub y than they did. Because they get 0.8 for f sub x. Sounds good, no pro? Under that McNeil Island tonight? Really? In 1.57. Actually, did I do something wrong here? Because from that graph, there's no way f sub x is 0, right? Or is it? Because it's parallel to the x-axis. Dude, how do you interpret a partial derivative again? If it's, oh yeah, it's really hard to tell based off just that graph, I guess. I'm a little worried that I did something wrong though. It's parallel to the x-axis. I don't know. You know what? I can give this a bit more of assurance if I make Wolfram Alpha get the partials for me. Uh, 0.2x to the fourth plus 0.8y to the sixth minus xy. Okay, and we could even evaluate it at that point too. That'd be great. 0.8x cubed minus y, okay. With xy equal 1.8. Let's see if that works. 0. Okay, good. How about for y? 0.57. Okay. So Wolfram Alpha agrees with what I did, I think. Okay. See if we can work through it with this person, and then okay, so this person didn't respond back again. A bit hard to tell if we're supposed to interpret y of t or z of t as the height you throw the ball from, but I think the problem only makes sense with z of t being the height. You need to find a and b such that z of t equals 1. Or you need to find the 2 points to get a and b, or the 2 values of t. I think you need to get okay. And then this person replied back. Oh, this person just dropped off the minus xy. Okay. So hopefully that was their person's problem. Oh, it's Rough Rider and they have a picture of Teddy Roosevelt. That's funny. I think that was his like nickname, which is kind of a cool nickname, I guess. Or I think maybe when he found like or he was like a veteran. He was a part of the Rough Riders or something like that. I don't remember. I remember learning about it in history class. I just don't remember exactly what it's about. Okay. Oh god, that looks horrible. I flux through a surface. Oh, that actually might not be that bad, but I don't remember that. I don't remember flux that well. I believe so, because the question specifically says it's thrown from a height of 1 meter and ends at a height of 1 meter, rather than giving a 3-dimensional point. Okay, so that person got their help. And I'll wait for this person to reply back. Let's see what got posted here. No Pro posted theirs first. Let's look at theirs. You have 2 coins of varying denominations. Non-negative real number. Okay. So you can have a coin of 0 value, I guess. Okay, that'd be funny. Choosing 1 coin from either end, so I assume they're lined up. Oh, in a line, duh. Okay, I should actually read the question. Prove A always is a strategy that ensures he ends up with at least as much as B. Oh, funny. Maybe that's just for the context of the question then with coins. It'd be funny if you could have negative money. Like, here, take this. Oh, you have less money now. Let me just, I'm gonna switch back and forth between that question and this one, because I want to make sure that I'm replying quickly to this person. Actually, it's kind of funny because basically, yeah. But it seems for this particular question, we only care about one of those. Since we're just giving info about height. Yeah. Yeah, I feel like there's like room for interpretation on this question because it's a little bit vague. But I don't see what else it could possibly be, so that's why I'm still like engaging. Rather than just leaving it for someone else to deal with, I guess. So 2n coins of varying denominations. Notice that if there are even numbers, it is not correct. $1.99.1. Or for odd numbers in that example, right? Because for this one, they have to be even. And the example you gave is just 3, right? That example makes sense if that's the case. Oh, they might. Ooh. They're typing. Let's let them type. So I would think, since we have an even number of coins, it's not enough to just always. You have to look in the future. You can't just only look at the two choices in front of you and always choose the highest one. I can't imagine that's a winning strategy. So you make another extreme example of like, 1.99.1.2, and that could maybe lead down the wrong path. Maybe not. Basically, c of t equals t squared. So set t squared equal to 1, solve for t. You should get 2 solutions, which will be your A and B. So I'm wondering, this almost feels like a, it's gonna be like a binary search or whatever the term is. I think there's a different question you posted that was almost of a similar thing with the cows. But I'm trying to think of something where like player A chooses whichever half is a higher total value, or maybe player A would want to avoid that until they get to the highest one. That was actually completely different. Okay. It's still based on even and odd numbers, I guess, or the even and odd numbers still like matter, but I guess for this one we're only caring about even. That's why I thought of it. Also, let me, in case this person asks me, I want to look up what the formula is for arc length. You like contradiction here? Ooh, okay. Is it gonna be multiple integrals? Oh no, it must be line integrals, right? It makes sense to have actually wait. Where would it be? Maybe it's line integrals. We want arc length. Here we go. Okay, that's the formula that we want. Let's look back at what this person is saying. It's like what I'm getting tripped up on is whether A wants to choose, like if A should be more concerned with making their own best choice or with trying to give B bad choices to make. And how far ahead, like do you look through the entire line or do you only look, like, 1 or 2 points ahead? I mean, I guess for the sake of problem, you could just look at the entire line and make some kind of formula. The person hasn't replied yet. A made the wrong forced decision. Oops. So maybe I need an example here. So if we did 199 to 1, just an even number of coins. If you're player A, you want to take that. You want to take the one away from the 99 because now player B gets to go and they have to choose one of these. I guess their best move is to do the 2, but that leaves A with their pick of the litter between the 1 and the 99. Okay. So the thing is, it's not going to always be this extreme of an example where just one of the coins wins outright. One second. This person is replying back to me. You have these exact same approach from. Okay. That's reassuring. If you did want to get the 3-dimensional points, you'd plug in t equals 1 or negative 1, but we don't. We can keep everything in terms of t here because the formula for arc length needs to be in terms of t anyway. Technically, they're vectors, not points. I don't know if that's even an important distinction to make, though. That makes sense to the person. I feel like I could be explaining it more, but I don't want to explain it. I don't want to like over-explain it and just make it more confusing. So, what if we expanded out that 99? That's my concern. What if what if the 99 wasn't such an attractive coin? What if we did 145, just say 2, 3 to make it interesting. 45, 1. Oops. So I guess A would see that this side has more total value. I owe you a cat? That's right, you did ask for him the other day and I got preoccupied here. There we go. Then a little triangle nose. Whiskers, all that good stuff. There, that's your cat. Okay, before I go through the logic on that one, let me bring up the cat looks terminal. The cat is player A. At this point, we have we have everything we need, just plug it into the formula. I guess I didn't even realize, but the formula for ArcLink that I have on the site is for if we had only I and J. In this case we have a K, but it's all the same, I think. If I go to the part 2 of this, is it going to show me the bigger case? Oh, okay, yeah. This is basically it. I believe. Let me go back to the Discord. Plug into the formula. I should read all your Discords. Dude, I can't live with there being a notification in my Discord. I tend to mute almost every server I join besides my own. So I only get like the notifications if I'm pinged. But even then, if they spam at everyone, I just mute those too. Except for some servers. For some, I'll just deal with it. So I think at this point we have everything we need to plug into the formula for arc length. Oh, did you just ping me? I hate you. You literally just... Go away. Okay, so this person, I'm waiting for them to reply, so let's... You still hang out in that Discord? I tend to not go to it unless I have to, because it can be very like busy. Kaylani, thank you for the follow. Or it can be like a little bit too busy and people tend to get like a little like just talking about random stuff, but it is nice sometimes. Hard locked? Oh my, indeed. Hope you're doing good. Let me actually make sure this person hasn't replied. Okay, no, they haven't. Okay. So for no pro Bob's question, we did a simple case right there. Let's look at a slightly harder case. So I think, sorry, this will be a line right there. Separate them. I think, well, so if you're player A here, either way you have to expose one of these 45s to player B. The question is, which one is better? Like, the difference here is the 2 and the 3. So maybe... let's just try taking the one on the opposite side, because that's what my theory kind of is, that you go for the lower side, so you don't expose too much. So player A takes that one over there. So we have 45, 2, 3, 45, 1. Now B, I think, just wants to take the cash. 2, 3, 4, 5, 1. Now A would go for the 2. 3, 45, 1. Isn't A losing here now? Maybe not. B would take the 3. I wasn't keeping track of the totals. So B gets a 1. It's just a fun sound to play. Sometimes people will time it really well with what happens on stream. Depending on the situation. So A has 1, 2, 48. B has 49. So A chose poorly. So A, or I chose poorly. I shouldn't pass the blame off on A. A is not Indiana Jones. Where am I going right now? Oh yeah, I want to check the math Discord quick, and then I'll figure out what the best strategy was there. Okay. Let me actually, I want to plug this into Wolfram Alpha to get what the end result should be. Don't blame the cat. Oh, yeah, I already have it open in Opera, I think. No problem. Okay, so let's just quickly get the arc length of this from -1 to 1. This one we already fixed or solved. All right, Turisky, thanks so much for hanging out. I appreciate you. So it's our original f. Let's set up this integral. -1 to 1 in terms of t. Our original function, which is letters and numbers, t plus 2/3 t plus 2/3 t cubed. I think you just do it without the unit vectors. You don't do anything special. T squared, close parentheses. Like for the sake of this integral, you just get to ignore the I, J, and K, I think. I hope. Times the square root of the partials. Oh, wait. Yeah, okay, the partials for this, it's just the x in terms of t. So the x is 1 plus, that derives to 2t squared, but you have to square it because we're doing the magnitude. 2t squared plus 2t in parentheses squared. Wait. I did something wrong. I'll go back to it in a second. Okay, 2t squared squared. Oops, that's what I did wrong. 8. There we go. That should be it. Yeah, work soon, Brian. All right. Thank you for hanging out too. Okay, this should be our answer. 22 over 15. I'm getting a random phone call right now. I hope I did this right. I'm pretty sure I did. Like this form is only for the case where you have I and J, but I think it's just the exact same thing for when you have a K thrown in there. Yeah, I did. That's what I think about you. This person's still working on it. I'm trying to get through to my wife. Oh, we do have the same phone number. So for this coin problem from No Pro Bob, we ended up giving B the 3, and I guess that's the difference. So how would it, how would we do this better? Should A have taken the 1? No, because then that exposes the 45. So maybe A needs to have taken the other 1 at the very start. Yeah. And then B is going to take the 45. I don't see why not. Then A wants to take the 3. And this gets A to be better, I think. So now A has 45, 48, 49. B has 45, 47, 48. Okay, so A won there. And that time A went for the side with the higher numbers. Got a brunch date tomorrow, but you need to rearrange seeing my mom too. Oh. You're not just, you know, going for that threesome, but I get it. You're a gentleman. Yeah, the cat always wins. So, have we seen enough to draw a conclusion here? I don't think so. Because I still don't know if this is generally applicable or not. Maybe let's try another example. Maybe keeping it to 6 coins. Notice you have the same coins as player B in the first game. What do you mean the same coins? All right, Central, thanks for lurking. Like, thank God you're lurking. Same coins as player B in the first game. 45-3-1. Oh, from my first attempt on this same setup? Yeah, so... I did see, like, it's the same thing. I had the same results, just reversed for players A and B. Okay. And so that, is, I guess, is the key. I'm still not sure... Or at least that's the hint. Sorry, now that I'm checking on the math Discord to see if this person got back to me, but not yet. Idea is simple but hard to come by. I wonder if you somehow boil, like, there's only so many possible combinations of coins that you could have. I don't know. I have to be honest. I like, this is what the real solution in 10 minutes? Okay. Same coins as player B in the first game. It's fair enough. Let me maybe look at the problem that Brian posted even though he left. Just to give my brain a break from this problem. 1 minus x, x plus 2. And the point is 4, 1. Can you plot a point? I mean, I don't know if there's a point in plotting a point, but oh, you can. Okay, so you don't have an easy thing. Like if you had a point directly above the vertex, that'd make it trivial. But here you just have a random point. Let's take the coins and differentiate the odd and even indexes. Let's say you underline once the odds and underline twice the evens. Okay. So is there a way to do this without calculus, I wonder? Because I don't know what kind of class this person is in. You can force if you want all the odd ones or all the even ones. Because right here, if you wanted all the evens, player A could just choose 6, and then that forces player B to choose 1 or 5, which will either way will expose an even. Okay? And vice versa for if you wanted all the odds, you would take 1, and then player B will be left with just the evens. Hey Ben, how's it going? One of them must be bigger, and you just choose that one. Pretty good too. Had some fun math questions today. I was just looking at this one, but let me bring up Bob's thing again. So I was just working on this kind of in the meantime while, oops, I was waiting for people to reply back to the homework questions. Sum of all the evens is bigger. Oh. Just, huh. That is a simple idea that's hard to spot. That seems to be a pattern with your questions, which is fun. Wow, is there a scenario where the evens and odds are equal? I guess, and is there a different strategy that would work in that situation though? I wonder? Like, does that cover every situation? At least equal? Okay. Oh, at least as much. That's what the question asked. Yeah, I'm trying to give like simple cases. If you have like 1, 1, 2, 2, 1, 1. Is there a way that we could break that question? I don't think so though. I think you can always make it even. I do have a message on Reddit, so let's go check that. Okay. This person just saying thanks. Let's upload them. Let's go check through Reddit one more time and we'll go back to the math Discord if there's nothing new here. Someone has no answer. Okay, this is just good old algebra. So they want a general explanation for how to solve equations like this, not necessarily that exact equation. General way to think about solving these. The most important thing to remember is PEMDAS. Well, I don't even want to. Should I even say PEMDAS? Maybe I should just explain it without calling it PEMDAS. I feel like not everyone learns it like that. Technique is to deal with any parentheses first. Actually, okay. The general steps are 1, deal with any parentheses first. Well, deal with any parentheses, I don't need to say first again. 2, combine like terms, i.e. combine everything with an x and everything without an x. And 3, get the x term on one side and the non-x term on the other side. For this problem, oh shoot. Another very common, not another, but a very common error is to say x plus 2 equals 2x. When you have addition or subtraction, you can't combine the x and the number like that. If you have something like x times 2, you can say that x times 2. Time for bed? All right, Ben. Thanks so much for hanging out. Sleep well. X times 2 equals 2x. So with multiplication and division, they are allowed to be combined. Okay, for this problem, let's do step 1 and deal with the parentheses first. Minus 5 minus 3x minus 3. When you distribute the negative 5 in, becomes negative 5 times the negative 3x minus, minus negative 5 times 3, which then becomes 15x plus 15. Right? Right. So the problem now becomes 15x plus 15 plus 5x plus 4 equals -1. So the entire problem now becomes that. Let's do step 2 and combine x's and not x's. 15x plus 5x equals 20x, and 15 plus 4 equals 19. So we get 20x plus 19 equals -1. Now let's do step 3 and get the x's on one side and the not x's on the other. Quickest way I see is to subtract 19 from each side. So 20x equals -20. Now let's do the final step and divide by the number in front of x, 20. So x equals -20 divided by 20 equals -1. Okay. But I don't really mind giving away the answer for this one, because they're asking more about the general technique than the actual problem at hand, I think. Or it seems, and going through the entire problem is a good way to demonstrate what I'm saying. So